We will now discuss the solution of a problem from the section Coordinate Geometry. This problem is on the circle with the given extremities of the diameter of that circle. And this question has appeared in the Joint Entrance Examination Main held on 25th June 2022 in the first shift. The given question is, let the abscissae of the 2 points P and Q be the roots of the equation 2x square minus rx plus p is equal to 0, and the ordinates of P and Q be the roots of the equation x square minus sx minus q is equal to 0. If the equation of the circle described on PQ as diameter is 2 times in brackets x square plus y square minus 11x minus 14y minus 22 is equal to 0, then 2r plus s minus 2q plus p is equal to. So we are given 2 points P and Q, and the abscissa of these 2 points P and Q set are the roots of this quadratic equation 2x square minus rx plus p is equal to 0, and the ordinates of these 2 points P and Q are the roots of x square minus sx minus q, that is the quadratic equation, is equal to 0. And we are further given the equation of the circle described on PQ as diameter is 2 times in brackets x square plus y square minus 11x minus 14y minus 22 is equal to 0. Then required to find the value of 2 times r plus s minus 2q plus p. We now discuss the solution of the problem in detail. Let the coordinates of the points P and Q be x1, y1 and x2, y2 respectively. It is given the abscissae of P and Q are the roots of this quadratic equation 2x square minus rx plus p is equal to 0. Abscissa means the x coordinates of P and Q, that is x1 and x2 are the roots of this equation. This implies x1 and x2 are the roots of this quadratic equation 2x square minus rx plus p is equal to 0. Therefore, the sum of the roots x1 plus x2 is equal to minus the coefficient of x by the coefficient of x square, that is minus of minus r by 2, that is r by 2. The product of the roots is equal to the constant term by the coefficient of x square, that is p by 2. And we are also given the ordinates. The ordinates means the y coordinates, that is y1 and y2 are the roots of this equation, quadratic equation x square minus sx minus q is equal to 0. This implies y1, y2 are the roots of this equation x square quadratic equation x square minus sx minus q is equal to 0. Therefore, the sum of the roots y1 plus y2 is equal to yes, and the product of the roots is equal to minus q. y1 plus y2 is yes, and y1 into y2 is equal to minus q. And we know the equation of the circle with PQ as diameter, the coordinates of P is x1, y1, the coordinates of Q is x2, y2. So the equation of the circle with PQ as diameter is given by x minus x1 multiplied by x minus x2 plus y minus y1 multiplied by y minus y2 is equal to 0. Multiply. So in the first product, x square minus in brackets x1 plus x2 times x minus into minus plus x1 x2. In a similar manner, in the second one, y square minus y1 plus y2 into y plus y1 y2 is equal to 0. We know x1 plus x2 r by 2, and we know x1 x2 p by 2, and we know y1 plus y2, that is s, and y1 y2 minus q. So substitute. So this is after substitution we got. Now take the LCM, clear the LCM then. That will be equal to, that will be 2 times of x square plus y square, correct, minus rx, correct, minus 2sy, because you have taken the LCM, minus 2sy plus p, right, and minus 2q, you are taking the LCM, minus 2q. So that is 2 times in brackets x square plus y square minus rx minus 2sy plus p minus 2q is equal to 0. Let's call this as the equation 1. So this is the equation what we have, and it is given. The equation of the circle described on PQ as diameter is given to be 2 times in brackets x square plus y square minus 11x minus 14y minus 22 is equal to 0. So this equation 1 and 2 is the same equation, because the equation of the same circle. So the equations 1 and 2 are the equations of the same circle, therefore they are equal. Therefore the corresponding coefficients must be equal. So equating the corresponding coefficients of 1 and 2, we get the coefficient of x from 1 is minus r, the coefficient of 2 from the coefficient of x from 2 is minus 11. So minus r is equal to minus 11, therefore r is equal to 11. And in a similar fashion, minus 2x minus 2s is equal to minus 14, therefore s is equal to 7. P minus 2q is equal to minus 22. So this is r is equal to 11, 2s is equal to 14, that is s is equal to 7, and p minus 2q is equal to minus 22. What is required to get the answer? So the required one is, we have to find the value of 2r plus s minus 2q plus p. 2r is 2 times 11 plus s is 7, and minus 2q plus p is p minus 2q only. P minus 2q is minus 22. So 2 into 11 plus 7 minus 22. Minus 22 plus 22 cancels, and you are left with 7. That is your answer. Therefore 2r plus s minus 2q plus p is equal to 7. That is the answer for this question. And this is the detailed discussion of the solution of the problem from the section coordinate geometry, and it is based on the concepts of circle. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.